So good morning everybody, myself Acharya Vishvendra, and today I am going to discuss a worksheet based on the equation of continuity. So let's begin with things. So here is the worksheet. So let's start with the first question. It is that equation of continuity is based on, so it is based on the conservation of mass, and if density is constant, then we can also say that based on the conservation of volume, but conservation of mass is the general property over there. Next is we are being given a pipe of variable cross section. On the left side, area of cross section is A1 and liquid is entering with a speed V1. On the right hand side, area of cross section is A2 and liquid is leaving with a speed V2. Then we need to find volume flowing rate through the left. So the volume flowing rate or volume per unit time is given by the product of area and speed. So that will be A1 V1. Similarly, on the right hand side, the volume flow rate will be A2 V2. Now AV is constant. So we can say that the product of AV is constant. From here we can analyze that A is proportional to 1 by V. So if we draw graph between area and the speed, that will be a rectangular hyperbola like this. However, if we draw graph between area and 1 by V, so that will be a straight line just like this. And for a constant volume flow rate, AV is constant. So if we draw a graph between AV and A, that will be a straight line parallel to A axis as shown in the figure. Next is, if we talk about the volume flow rate V, which is constant, so that will again be a constant. Here it should be A, because otherwise that will be a constant, so it will be a point rather than a graph. So here it is area only. Next on, now we have a question that there is a variable cross section type of system, and from the left, liquid is entering with a speed 10 meter per second. Area of cross section on the left side is 10 and on the right side is 2, and we need to find the volume flow rate through left. So it is A1 V1, area is 10 centimeter square, speed is 10 meter per second. So on combining things, we have 10 is to power minus 2 meter cube per second, the volume flow rate through the left cross section. Now through the right, so volume flow rate will be same, so through right also that will be same, which is 10 is to power minus 2. Now we need to find speed V. So using A1 V1 is equal to A2 V2, we can say that V2 is equal to 50 meter per second. Now there is another question that there is a tap of diameter D. Initial speed of flux is U. We need to find first is area of flow. So area is pi r square, r is d by 2. So the area will be pi d square by 4. Next is volume flow rate. So volume flow rate is area into speed, so which is pi d square by 4 into u. Next is mass flow rate. So mass flow rate is density into volume, which is DAV. So that will be the expression for mass flow rate. Next is speed of liquid at a depth h from the top. So using third equation of motion, we can say that this will be speed at a depth h from the top. Next is area of a flux at that point. So using A1 V1 is equal to A2 V2, we can say that area is equal to this. Next is volume flow rate at that point. So volume flow rate will remain the same, so that will be equal to pi d square by 4 into u. So from here we can see that these worksheets are the basic level worksheets. Just needed to make sure that your mind-brain system develops certain algorithms, develops certain patterns which are optimized for your exam. So I hope these videos will improve your problem solving skill and will save your precious time and energy and help you in optimizing your results. Thank you and have a nice day.